Hi everyone, Tina here, and today I'd like to talk about proof. Specifically in this video, I want to talk about the essential skills that you'll need for proof questions in both the foundation and higher GCSE maths courses. I have made another video for more difficult proof questions that you'll only come across if you're doing the higher course. Okay, so let's start by thinking about what does it mean to prove something in maths? It means that we're going to use logic to show whether a mathematical idea is true or not. Personally, I think it's easier to prove that something is not true because you only need to come up with one example to show that it's not correct, and then you're done. Let's do a couple of examples of this. Example 1, show that this statement is false. The difference between two prime numbers is always even. So first of all, we need to be comfortable with what prime numbers are. So if we list out the first few prime numbers, we've got 2, 3, 5, 7, 11, and so on. Because remember, prime numbers are numbers which only have two factors, 1 and themselves. If we look at these prime numbers, we're trying to find two prime numbers where the difference between them is in fact odd. Now I can see 5 take away 2 equals 3. That's odd. So the statement is false. We've shown the statement is false because the statement says that the difference is always even, but we found an example where the difference is in fact odd. Example 2, Bethany says that 2x squared is always greater than or equal to 2x. Decide whether she is correct or not, showing working to justify your decision. So with questions like this, you want to do a bit of trial and error. So let's try maybe x equals 3 and see what happens. So if we do that, then 2x all in brackets squared is going to be 2 times 3 all in brackets squared, which is 6 squared, so 36. 2x is just going to be 2 times 3, which is 6, and 36 is in fact greater than 6. So just from this, it looks like Bethany might be correct. However, let's try and find an example to show that she's not. Maybe try a decimal number. So let's try x equals 0.1 and do exactly the same activity. So 2x all in brackets squared will be 2 times 0.1 squared, which is 0.2 squared, which is 0.04. And then 2x is just 2 times 0.1, so 0.2. And in fact, 0.04 is less than 0.2. So we've shown that Bethany is incorrect. Now we've seen how to show ideas are not true, how do we show that something is true? The method you'll use will depend on the style of the question, so let's have a look at a few examples. This one is a piece of algebra. So it says show that n plus 3 squared take away n minus 2 squared is the same as 5 brackets 2n plus 1. Just go ahead and start expanding and simplifying things. So I'm going to start with the left-hand side and I'm going to expand those double brackets there. So let's use whatever method you're comfortable with. I personally use FOIL. So I'm going to go for n squared plus 3n plus 3n plus 9 minus, now this is quite important to keep everything in brackets in that second set of double brackets because you do have a minus before. So you want to be careful that you're going to take care of that. So safest to keep it all inside a big pair of brackets and just expand again normally. So n squared minus 2n plus 4. Personally, I would then tidy up each part separately. N squared plus 6n plus 9. Take away, all in brackets still, n squared minus 4n plus 4. Now, earlier I mentioned about keeping that second part all in brackets so that you can then take care of the minus. So let's do that now. So we've got n squared plus 6n plus 9 still, that doesn't change. But then this part becomes minus n squared plus 4n minus 4, because that minus will have a different effect on each term depending on whether it's positive or negative. Remember, two negatives make a positive. Tidying this up now, so n squared take away n squared goes away. 6n plus 4n gives us 10n, and then 9 take away 4 gives us 5. So we've got 10n plus 5. Looking at what we're trying to get to with a 5 factorized out, let's go ahead and do that. So that is the same as 5 factorized out, 2n plus 1. So we know we've done it right. Next example also involves quite a lot of algebra, but it's a slightly different question. So let's have a look. We've got show that if x is an integer, then this whole expression here is a square number. I would just make a start expanding and simplifying and see what it gets you. So let's go for it. 35 plus, and then double brackets, take away this, expanding, so 9x squared plus 3x plus 3x plus 1 minus 8x squared plus 6x. Just be careful there again, double negative makes positive. Now we can look to tidy up. So we've got 9x squared take away 8x squared, which gives us 1x squared. Then we've got 3x plus 6x giving 12x. And finally, we've got 35 plus 1 giving 36. Now, does that look like a square number? Not yet. However, we have ended up with a quadratic. So we can think about factorizing that quadratic into 2 brackets. When we do that, we will in fact get x plus 6 in both brackets. And that's great news because you can write that as x plus 6 all in brackets squared, which is in fact a square number. Last example, again, a bunch of algebra, but this time they want us to show that a is a multiple of 4 for any integer b. A being this expression here. I'm just going to rewrite that so we can have a look at it. Just go for it with expanding, see what happens. So let's do it. 3b plus 27 plus 5b take away 10 plus 3. Tidying up, we've got 3b plus 5b, so 8b, 27 take away 10 plus 3, so 20. And then how do we show that this is a multiple of 4? Well, the trick is factorize out the 4. So bring a 4 on the outside, and then on the inside, you can put 2b plus 5. And this shows that it is in fact a multiple of 4. Because if you think about it, we're saying here that's 4 times anything inside that bracket, and 4 times anything is a multiple of 4. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already, and do share this with anyone else that you think might find it helpful. Thanks, and see you next time.